welcome to a hands-on introduction to TensorFlow and machine learning. I'm one of the organizers of GDG Kansas City. Where's your, there it is. Perfect. So we are GDG Kansas City. My name is Jay Whitsitt. We have Roger Odell, who is joining on the virtual event, and our newest organizer, Kirti, who will be presenting today. You found us somewhere, so we're on most of the socials, Twitter, we always post our events to, but our main source that you can find our events is on gdg.community.dev, as well as Meetup. If you join our group, you'll get emails whenever we post a new event, as well as any videos that we'll post after the fact. So first, I wanted to say a huge thank you to our sponsors, Dexter and T-Mobile Accelerator. That's where we're physically at today. Do you want to talk about Dexter a little bit?
Yeah. All right, are we live? All right, cool. All right, I appreciate it. Awesome to host everyone. When Jay was telling me about this group about a month ago, the first thing that came to my mind was, thanks for the spot to introduce who Dexter is here at the T-Mobile Accelerator, was how much I miss my Android smartphone. So at Dexter, we build software across the industry, but currently we focus on iOS devices and deployment of our software on Apple devices. So I was forced to change to an iPhone, but I still miss my Samsung Galaxy device. And one of the things I'll talk about today is the next step for Dexter is as we look to go cross-industry, we're also going to go cross-platform. So Android will be an area of focus for us over the next 12 months as we evolve. So at Dexter, we focus on data at the speed of voice. So the problems we're trying to solve, think about this in any industry across the world, you have human inspectors inspecting either the crops that are grown to feed us, folks that come to your home, whether it be pest inspection or it could be even somebody just cutting your lawn. There are people that have very hands-on, eyes-focused tasks. And the only way that they can capture key data today, whether it's at the grassroots of the food supply chain or your pest inspector after completing an application of insecticide at your home, for government regulatory reasons, as well as for creating a report that they hand to you as a customer, they have to literally write up a report at the end or type it into a tablet and it gets emailed to you. So at Dexter, we believe there's a better way. And so having those inspectors keep their hands and eyes focused on the job at hand, we build software and using industrial grade headsets anchored to your own, bring your own device model, so a smartphone, and in the future, any Android smartphone as well. We say keep your smartphone holstered in your pocket and using that industrial grade headset, keeping your eyes and hands focused on your task. You literally are speaking your key observations, measurements, and other types of observations, and we do the rest. We smart populate your reports and checklists, and we integrate that into your company's backend system. So that full suite is what the Dexter system is built to be today. And we have customers, our roots are in food and agriculture. We started about 5 years ago, classic software startup, investor-backed, and based on going through a couple of rounds of early investment, we were able to bring on additional members to our software development team, continue to penetrate the food and ag industry with a lot of the enterprise companies there, dealing with plant production as well as animal health, animal production. And now in 2022, we rebranded to Dexter because we're looking at adjacent industries such as warehousing and logistics, as well as insurance. So you have insurance adjusters that are now using Dexter to basically capture their keynotes and observations while they're out in the field, and we populate their back-end reports that get emailed or sent to their customers. So appreciate it, Jay, for having us sort of present who we are. We are interested in additional development resources and talent, and because we'll be looking at Android development over the next 12 months at some point, if you have any interest in learning more about Dexter, please get with Jay. He has my contact information. Sorry, the presentation didn't connect today, and we'll be happy to talk to you. Thanks so much.
Thank you. Thanks again for having us here. This is a great space, and hopefully we can use it again. All right. So with that, I'll introduce Kirti, who's our speaker today, to present on hands-on intro to TensorFlow and ML.
Good. Hello, everyone. I am Kirti. I am a PhD student at UMKC. I recently joined GDG as an organizer, and my PhD areas of interest are deep learning. So yeah, that's about me. We can connect sometime to just know about me, but I really want to get started with this. So first, we'll be using TensorFlow. TensorFlow is a Google's open source framework. And when I say framework, it's because framework is pretty much different than libraries. Even though we are using TensorFlow, we'll be using a different library to get to the machine learning, to be able to do artificial neural networks and things. Libraries provide us a reusable code that we can use, whereas framework enables us to use libraries. So both are different things, and a lot of times people get confused between frameworks and libraries. So that's about TensorFlow. And yeah, before we get started, there are two ways of using TensorFlow. One is you can download Anaconda, and once you download Anaconda, you can create a new environment with TensorFlow. And I personally prefer to use Jupyter notebooks in Anaconda. And yeah, Anaconda might pop so many errors while installing TensorFlow because it is very particular about the environment variables. So if you're facing any issues, you can use Google Collaboratory. It's a really good alternative that you can use without having to install any libraries. Everything is pre-installed. All you need to do is just write your code and get started with it. So yeah, let's get into what's machine learning. So machine learning is where we want to predict outcomes based on the input. So when we say what's learning, learning is taking feedback, implementing the changes to be able to get the desirable output. For example, we are predicting the weather, and to be able to predict the weather, for example, we are just limiting it to rainy or sunny because then there will be so many parameters that get involved into it. So there will be variables such as clouds, sun, and humidity, temperature. There are so many things that that go with it. And yeah, machine learning is majorly concerned with algorithms that will be able to transform the data we feed into the outputs. And when we say a machine learning system, it means that it will be trying to build a relationship between the input variables and the expected outcomes. And this is the interesting thing. There are types of machine learning, and machine learning we categorize it as a subset of artificial intelligence. So the three major types are supervised, unsupervised, and reinforcement learning. Let's get into supervised learning. A real life example of supervised learning would be such as I'm playing a treasure hunt, right? So I'm given clues. Based on the clues, I learn something, and then I move towards my outcome. So it's like self-explanatory. Supervised is just taking an input and learning through the input, and I know what the outcome is expected to be. So that is supervised learning. And unsupervised learning, I do not know what the outcome is. I'm just given raw data, I'm just trashed with it. I make my own patterns. I determine how the patterns would be. For example, there are credit card scams, right? So when I'm given a scam, I know it's a scam, but how do I categorize them again? So I don't know what type of scam it is unless I work on it. I determine a pattern in it, and then come to the outcome. And a real life example for this would be like I'm entering a maze. So I don't know what the outcome is. I'm just going into it. As I move into it, I figure out what it is, and maybe next time I expect. So that's how the machine learns in unsupervised learning. And the reinforcement learning is like I'll be rewarding for every move that is towards the expected outcome, whereas I'll also be penalizing any unexpected outcomes. For example, I'm training a puppy, right? If I'm training a puppy, what I would do is if I ask him to sit, and if the puppy is sitting, I will be rewarding the puppy, right? So I am rewarding for an expected outcome. And in penalizing, if the puppy is like on potty training and he would just be in the house, it is not an expected outcome. I would put him in the crate. So I'm penalizing him. So that's reinforcement learning. Reinforcement learning is pretty much long. It's not one algorithm that goes into it. It's multiple methods that together we combine to be able to get to the expected outcome. And this is right now like a good research area to be working on. Any questions on this for now? Are you like on the page with me? Hi. Any questions so far? No. Nothing in the chat I see. So moving forward, did I miss anything? No. Okay, we'll be talking about neural networks. First, actually, I will go to the next slide first. Why do we have that name neural networks? So if we see how like neurons in our body are, the dendrites, what they do is they carry information to the cell, and there the information is again processed, and there is a thing called impulse that determines if the information is processed or if it is what's the expected outcome. So, and for the same output for the same input, two people might respond in a different way because their mathematical function, terming it as mathematical function, because the way I process information might not be same as the way you all might be processing. So, which is why machine learning involves learning to determine what relation fits between inputs and outputs. And if you see in the slides, the structure of neural networks is similar to the way neurons are in our body, in our brain. How do they process information? So, which is why it comes to the name neural networks, and we call them often artificial neural networks because they're not natural. And yeah, what are neural networks? They're just like a bunch of interconnected neurons, and these neurons are the nodes that we define. And every node has parameters that keep on updating every cycle it's a learning is happening. And these we call as model parameters. And every time something is training, model parameters determine what the output is. We can definitely calculate a mathematical equation based on how we structure our neurons, but it's hard calculation. So let's just understand that everything is connected and information passes through those neurons to be able to get to the output. And there are two phases. We can say three primary phases in machine learning. That is training our model. So for training, what I do is I give it both input and output. If it is supervised, both input and output, it will learn how, like, for what input, what's the expected outcome. There is a thing called feedback. So when that feedback is happening, there is a lot of matches. we calculate gradient descent and how like my output is supposed to converge. If you're not diving deeper into that mathematical aspect, if I'm telling my, it's like I'm telling my model that if you see this input, you're expected to give this output. And when we have similar inputs and expected outputs are given, it tries to build a relationship between these parameters during the training phase. And the second phase is validation phase. This is also seen by my model. We have some data for which we both know input and output. All we want to do is validate if my model is predicting the expected output, right? So I try to predict it without giving the input, without giving it the output, and then I compare the output given by my model and the actual output. This is like validating. And then testing is purely like I do not have like what the output is. I don't know. I'm just expecting my model to give me the right output, but it depends on the training accuracy and validation accuracy that we get, that we can say, oh, 98% my model is right this time, right? And yeah, so the prediction is based on the relation established during training. And then, yeah, we have talked about it. And then deep learning. So deep learning is again very specific. It's very subset of machine learning. When we talked about machine learning in general, we know we have a neural network. So and then I think I missed a part. So there are like hidden layers between my input and output where mathematical equations or relations are formed. So these hidden layers are the places where magic happens, where all this learning process goes on. So yeah, when it comes to deep learning, it is much more like we have multiple levels of learning. I have so many hidden layers that for every hidden layer there is an output I expect, right? That output is again fed as an input to a new different model. I don't think I can use whiteboard, but yeah. So when I see, okay, I'll take you here. So on this one, when we see the first network, we only have one hidden layer. Its input is my actual input, and then we have output, right? But when we see the next one, my input is fed to a different layer, and then it gives me an output. Its output is again fed to another layer. So if I maybe divide these into, if I just remove this is again another network, right? And if I just remove this is another network. So it's like multiple networks. I'm just keeping on feeding the input so that the parameters are more accurate, and it gets that time to better understand the pattern. So yeah, deep learning is basically inspired by the way our brain processes information. Sometimes we do intermediate learning, right? We take some input, based on the output, we do further steps. So it's similar to that. Intermediate learning, learn at every step of the whole process. And yeah, deep learning is complex. It's high on computation as compared to normal machine learning because we give it so many neurons. Some neurons might be shut during learning because it's not needed. It will determine which neuron is needed. It will determine which is not needed, and everything is connected. In deep learning, the models are deep, and that's where the name comes from. And for deep learning, we need large amounts of data. If I give it small data, the relation might not be very accurate for the system to be predicting it. Yeah, that's the difference between shallow and deep neural networks. For shallow network, it's either no hidden layers or just one hidden layer. And for deep neural networks, there has to be definitely more than one hidden layers. The more the layers, the better we expect the outcome to be. But then we don't want to add too many layers because it's high on computation. So let's go to some basic terms to understand. And as I said, Keras is an open source library that will help us build artificial neural networks. It has so many methods and things involved in it. First is input dimensions or shape. I think I would want to share my collab. Mm. Just give me a second, guys. Yeah, there we go. Is the screen on the screen share? It is not?
It was doing a tab.
Okay.
Change it to the screen.
Yeah. So let's do this. Yeah. So first thing, Keras needs a framework on which it is running. Right now it's TensorFlow. It can also be on Piano. It's Piano. I don't know the pronunciation that we use here, but it goes by Theano. And there is another new framework that people are still experimenting on, but TensorFlow is widely accepted, widely used because it's very simple, and you don't really need to know everything that's in the mathematical aspect of machine learning to be able to build models. And then Keras is the library that's giving us access. Oh, okay. I'm sorry. Yeah. So Keras is the library that's giving us access to all the functions that we would want to use and things. And yeah, and obviously data is very important. Data is the key to whatever we are doing here. We need input and we need output. But how am I supposed to explain it from here? Maybe I just need to get there somehow because. Can you just switch the whole setup a bit there so that I can explain it on that?
Oh, but that portal so far. Why don't we do it over here then?
Yeah. Do I have to pull everything back again? Yeah. We are back here. So any questions on the basics that I have talked about involving neurons, involving layers? No? So we have seen the map of how neural network looks like, right? So every column we can treat it as a single layer. There are two ways of building models. One is stack each layer upon itself, and the other is, as I said, feed input of each layer to the next, output of each layer to the next input. So the way when I'm stacking these, it's called sequential model. And when I'm feeding input of one layer, output of one layer to the input of the other, it's called functional API model. I use both of them, but right now we are working on sequential models. And in Keras, we have like models, layers, optimizers, and there are two more things that we need to talk about before we get to this. One is optimizer, and the other one is loss function. So loss function is something that determines how accurate output is. Depending on the loss function, we adjust the terms, weights, and biases that we talked about that we have for each node. So, and then optimizer is, just give me a second. Optimizer will help me mold that function that I'm expecting to get it. Based on the loss function, optimizer is doing the job of adjusting those parameters, how my learning rate is set and how my weights, by how much amount my weights and bias are modified for each step. It's not like, right, I know my output, I need to adjust this term by 0.5. I won't know it for sure. So there will be a limit that I will set. So for every loop my training is happening, my weight and biases are supposed to be updated by 0.5 or 0.2 or 0.001. That's the least we go to. And then for data, I am using a library called NumPy. NumPy allows me to just, I generated random to be able to demonstrate how training actually happens. So from NumPy, I just generated like 1,000 random arrays of 100 size. So they are just vectors. And then I also generated random labels. I only had labels too, that's either 0 and 1. And I have 1,000 labels. They are randomly assigned to random data. And then I am splitting my data for training and validation. I am putting a split ratio of 0.25. So 75% of my data I'm using for training and 25% I'm using for validation. And as I said, here is where I define my sequential model. So as I said, sequentially stacking layers upon each other. And then I added a dense layer of 32 nodes. So basically, an input dimension is one thing that is very important to be specified in my first layer. There are ways of specifying input dimensions. Right now, I have given it 100. That means it knows that each input has 100 size, right? Or I can also give it a tuple that will show it that it's 100 and there's no other y dimension. So it's either I specify input dimensions as 100 or I can give it as input shape in a form of tuple. So tuple is basically just it's just like giving like size, the way we specify sizes, right? So an activation function, as we have seen in the diagram of neuron, activation function will help us determine the output. Based on the levels of the number we get, activation function helps us to reach it to a particular value. We can call it like a threshold. So if it's above something, it's output A. If it's below something, it's output B. That's how activation functions act like. There are different activation functions that we use, but preferably in the model we use either ReLU or there are some other activation functions that are widely used. So I have added 2 hidden layers. Sorry, just 1 hidden layer. This is my input layer that has like 32 neurons, and I'm giving it input dimension. And after that, I have my output layer, and I'm giving it only 1 because I have 2 labels. I want it to determine if it's going to be A or B. So I only need 1 output. Based on that, I can say if it belongs to 1 or if it belongs to 2. And this number will depend on how many classes you have. Classes as in, for example, I have a problem of classifying 3 balls into 3 colors, red, blue, green. In that case, I will be giving it 3 because I have 3 different classes. And my activation function wouldn't be sigmoid. Sigmoid is like, it's similar to giving a threshold. So it's either 0 or 1. So here, this output will depend on the problem that we have, and we can see it in the next example. And I'm compiling it using optimizer and loss function. Optimizer, I'm using Adam. There are various optimizers. We can actually go to Keras optimizers to read more about each of these. And here, fitting the model is where the training actually happens. We give it on what data we're supposed to train, X-train and Y-train, and for how many epochs, for how many in our model. And validation data will make sure that it tests on this data and it matches with the output, and that's how the model validates. And verbose just prints your epochs. What are your values for each print? And yeah, that's pretty much it. I can run the code so that And yeah, I have printed model summary. Here we can see that we have like 3 layers, and we have our input with 32 nodes. So my output will have the size of 32. And here none, it's specified because it still doesn't know what the input dimension is. So it will take any input dimension. And then this is my output layer. And the number of parameters, as I talked, parameters are weights and biases. And based on that, the system will compute our model parameters. And this is how we are training our model. This is pretty quick because the data is not complex, it's randomly generated data. And as we can see, our accuracy is about 50%. And if we really want to check how it is, what we can do is we can do like model.predict, and I just want to predict it on a random numpy array. But we will not be able to validate that this is true, primarily because we don't know what the expected output is, because I have generated this data randomly. So we'll see another notebook where we can actually have an example of handwritten digits, how we are classifying these handwritten digits using neural networks. Any questions so far? I know this has been a rush, but let me just check chat real quickly. No questions. Should I just move ahead? Is the space fine so far? I don't know.
You're doing great.
Thanks. I hope so. And is the screen visible now? Yes. So MNIST is basically like hello world problem that's widely used in machine learning. We have handwritten digits that go from 0 to 1, which means we have 10 classes now in which my problem could lie. And let's go. So initially, as usual, we are importing all the required libraries. Then how do I load data set? So this data set is already available in Keras. They have included it under keras.datasets. Directly get it from there. And when you load it, you will have both train and test. And you determine in what variables you want to name it, like X train, Y train, or maybe data train, data test. So you determine in what variables you want to load this data into. But by default, it will give you 4 variables, train and test, that is already split. You don't have to use any other method to be able to split this data. And if we see what's the type of input here, they are numpy arrays. So basically, we have a 2D array with image values in it, pixel values in it. And as we have seen, the simple neural networks that we have worked on, they do not take 2D inputs. They have like single feed neurons, so we need to vectorize our input to be able to feed them. There are neural networks that work on images, that work on 2D input. Those are called convolution neural networks. So it is further deeper into it. So for simple neural networks, we do not feed 2D data in it. And yeah, so let's just see how like a simple image looks like. So I just plotted a random image. It's a 2. MNIST data is not very huge. It's a low quality data, but yeah. And then we are working on reshaping the input. As we talked, I need to feed it a single vector instead of a 2D vector. Right now, shape of each image is 28 by 28. So what we'll be doing is we'll be having, for each row, I'll be appending it to the next row. Like I'll be bringing all the rows, I'll be appending them one after the other. So basically I have a vector of 784 dimension. And once we have worked on that data, we'll be, and yes, the data type, it's up to you to what data type you can use, but preferably it's, because float gives it more room to take values that are in decimals and stuff. So, and since pixel values range from 0 to 255, we'll be scaling it down to 0 to 1. And since we have float values, it will have that room to go into the buffer. Scaling data, all this process we are going through, it's called data pre-processing. It's basically we are cleaning our data, or we are modifying it based on what is needed for the model. And data pre, so plays a crucial role because it will be determining, just give me 1 second, I don't see that. Yeah, so data pre-processing would play a very crucial role because I will be actually determining what sort of data I need. So here it's not the job of the machine or an algorithm. It's us, how much we are understanding our data, how much I know that this is where the actual information lies. So I might need to extract it. So for various inputs, we might need different sorts of pre-processing, such as some data sets might have outlier points. Like that point is very much away from my cluster, I might not need it. So we'll remove any such points that are existing in the data. So I have defined a very basic model with not many layers, and we are compiling the model with optimizer and loss function. It is not necessary that you need to use optimizer and loss function, like any particular one. Based on the problem you have, you can read like what optimizer and loss function would fit best for you. There are other methods of using how my targeted labels are. Based on that, loss function depends. But for optimizer, you can go for any. So, and yeah, this data set, we are pretty much, I'm fitting it for 15 epochs. And when I say an epoch is one round where I am feeding input, I am getting my output. Based on the feedback, I'm training it again. So one cycle of this whole process is called an epoch. So number of epochs I'm training, this determines how we are having it. So here we can see what is validation accuracy and what is training accuracy for every epoch. So here the accuracy has gone up to 95% on validation data. We are more concerned about validation because in validation what happens is I am first predicting and then determining if it's correct output or not. But whereas in training, the model already knows what the expected outcome is. So validation is basically like cheat testing how my model's performance is. Uh, and then I'm just so when I do model.fit, I am storing it in a variable, and this variable will store all accuracy values, all loss values that are at each epoch during the whole training process. So it's easy to have a plot and determine how accuracy has gone. These are the accuracy plots and these are the loss plots. So uh, in this variable, it's not needed that you use history variable. You can assign it any variable. Dot history will give you access to the accuracy and loss values. And inference is technically like I am testing it and I'm seeing how my model is performing. So basically reaching to conclusion through a process. I'm just predicting on a random test data, and when I'm predicting, what it is giving me is values. So these are like probability values of what class it can be. we have 10 classes, as we have seen, 0 to 9. So for each class, this input, what is the probability that it belongs to a particular class? And now if we want to know, we pick the class with highest probability, whatever is the highest probability. And then if I plot it, yeah, it's 7. It predicted that the highest probability that it's a 7. And if I actually plot the image, it is 7. I don't know. Yeah, so many technical terms that are still involved in it. I don't know how to get to them. Yeah, when I have multiple classes in a model or in a problem, it comes under classification. Classification is, again, it can be supervised or unsupervised, but since we know what are my target values, it comes under supervised classification. And when I'm suppose classifying email as a spam or not, it is, again, when I'm feeding my email into it, I might not know if it's a spam or not, but since they already have labels, I have labels guide your machine to get into it. But whereas suppose I want to classify Android users and iOS users, it becomes a cluster again. So there might be somebody who would not use both of these. So it will be forming clusters. And when it comes to clusters, it's not, I'm just giving it input, like people use so and so things. And for example, iOS users might be using FaceTime, whereas Android users might be using WhatsApp or some other app. So based on those usage details, these I can consider as the parameters, and the system will learn that if a particular person is using such sort of things, they are classified into it. So it's basically clustering the things. So it's unsupervised learning. Let me get back to screen. So any questions on this again so far? Yeah. So this is basically just a meme that I put on. So what we expect when we hear machine learning or deep learning, and what's the reality? The reality is just math. There is so much math in this. It is super complex, but when we see the outcome, it looks super fancy, that, oh, that's so cool, that's so much happening there. But trust me, the reality is just math. And these are all the steps that I have walked through during the programming session I have taken. So first, we import libraries. It's super important because none of the code is something we have written by ourselves. We are just reusing the codes in the libraries. We can implement them from scratch, but then what's the use of writing it when it's already existing? And for data set A, you can always use existing data sets. If not, there is also a process of data collection where you collect your own data based on what the problem requirement is. And when you collect data, it's more hectic process, but then you know what you need to work on. If there is existing data, there might be a high chance that it's already worked on, such as if I'm working with images, I need to make sure all of them come to the single dimension, right? I cannot feed my network a different dimension every time. At the end of the day, it's still machine. So I might process information that's different each time, but a particular model will not. The information needs to look similar so that it understand it's in a better way. And we split data for training and validation. As I explained, like, it helps me test data. It's very mandatory that it's unseen by the model, because at the end of the day, that's how real life is. If I build a model, if I haven't tested it, oh, my training accuracy is 98%, but when I feed in any unseen data, it might react very differently to that. So we don't want that, which is why we need to save some chunk of the data that is completely unseen by the model to be able to know how it responds to unseen data. And after that, we build our model based on the structure. There are dense layers allows you to connect. When I say dense layer, each node is connected to every node that is in the next layer or in the preceding layer. So it's deeply connected layers. And then we compile the model with loss function, optimizer, and metrics. When I say metrics, metrics are the ways in which we monitor our training process. For now, we considered accuracy as a metric. So for each step, we can see what the accuracy is, how it is changing, by how much it is adjusted. And when we are specifying optimizer, if I'm specifying it directly, it will take whatever are the default values in Keras, but I can also have an option of specifying learning rate. Learning rate is by how much value my weight per epoch after one training loop, how much I'm updating that weight by. Higher learning rates will make your model train faster, but they might not converge. They might miss that convergence point. So we expect our convergence to be somewhere down in the steep. It might miss having like higher learning rate. So ideally start with a lower learning rate. If your model is taking too long to train, or if it is super uh, it's not training at all, then we can try increasing the learning rate, setting it to higher values. When I say higher values for learning rate, trust me, zero point 0.5 is a very high learning rate. The average range that we usually start by is 0.001 or zero point 0.01. So that's how much we adjust our weights. And usually these weights, when I initiate a model in Keras, these weights and biases, initially they are set to random values by default, but you can always start with zero as well. Zero will make sure that you don't get any bad values that will not lead your problem to any solution. And then we train the model while validating, and then we test on unseen data. So test on unseen data is the final step, which is again very important, because we want to know how our modeling has its response to unseen data. That's it. I'm done. Oh, I wrapped up. Yeah. Any questions? Yeah. Yeah. When to use this and that. There's no restriction that you want to use. Okay. The question is that I have mentioned that there are two types of models, sequential and functional API. So the question is when to use which model. There is no specification on when to use which model. Whatever is convenient for you, the way you understand, that's what matters. Because one is stacking layers upon each other, and the other one is you're treating every layer as an input and you're feeding it to the next layer. So I haven't really shown how functional API models are built, but when you read more into it, you'll just understand that, okay, I define my input layer, then I define a function that will take that input layer as input again. That becomes input to the next layer. And that next layer, again, it becomes input to another hidden layer. So that's functional API. Basically, I'm just mapping each layer to the next layer. So there's no specification that you're supposed to use any. Sequential, it's easier to build because what happens when building functional APIs, you might forget like the previous variable. You assign a lot of variables in it to each layer. Here, you don't assign any variables. You just keep adding layers. So in terms of computation as well, sequential is better. No. Input. It's primarily trial and run. People used to define these layers very back in the start of machine learning. Right now, we have so many state-of-the-art models that are existing. People just prefer to use those existing models and then try to work on their data. But there is no limit to how many layers you want to use. If the model thinks that it doesn't need some layer, it will just set all the parameters to 0. That's it. Or 1, whatever it doesn't need, it will set them to 0. Whatever it feels like there's nothing to do, it will just make it like identity. Whereas like such as multiplication by 1, I will again get the same thing. So if you are working with complex models, there is a high chance that you'll end up having better accuracy, but then there will be so much in the model that won't be really useful. Yeah, I'm sorry, I didn't repeat the question. His question was, how do we determine how many hidden layers we want to have, or how many nodes we want to have in each layer? And based on nodes, the classic terminologies, you use anything that's in powers of 2 because it's easier for us to understand. We don't pick really odd numbers, but there's no rule that you have to take powers of 2. You can set how many ever you want. Suppose I have input that is giving that's its dimension is 100. I am getting its output in 32, but I can also make it 500, and then those 5 next layer. So yeah. Anyone?
There is one question online.
Okay. Any guidance or suggestions on how we can obtain training data that is clear of any copyright concerns? And yeah, one popular website I use is Kaggle, Kaggle. So here they post a lot of I can say open source problems. They give you data set that you're free to use on anything, and without copyright issues, if you're working professionally, then you need to request data sets. So there's always a license that comes with it. But if you don't want to use it, anything that's available to download online, you're free to use unless you're misusing it. So
I did. Why are you using this other program to look at a Jupyter Notebooks file?
sorry, why am I
The
using?
Jupyter Notebooks file is the local file,
Oh,
but it's not in Jupyter Notebooks.
yeah, it's a Google Collaboratory.
Okay.
Why am I using it is because when I'm using Jupyter Notebook, so it's like it's very complex. I need to install all the libraries, and if anything goes wrong,
So,
it's so frustrating that it might pop error. But Google Collaboratory has everything installed. Anything that's related with Python comes with it. And if there is something that you have developed and you want to install that library, you can always install it. So I'm using Google Colab because it's really
you don't
really
have to
easy.
go and import all
Yeah.
these
The only drawback I see in using Google Collaboratory is they don't give you a lot of GPU or CPU for computation. You don't have a lot of RAM. So if you have something that you're running so much that would use so much of memory, then you might have to upgrade it. But apart from that, if you have good local resources, you can connect them to Google as well, to the Collaboratory as well. I personally suggest people using Collaboratory because you don't have to run into all the runtime errors and stuff. Yeah. Any more questions?
Yeah, I have one
Yeah.
connected to Tensor. So we have a lot of data.
Yeah.
We know the category and the values. We have the input, we know the output ranges. So we can do machine learning against that, those known parameters. Now there's another set of data we collect from human voice that initially the humans think it's quote unquote unstructured data.
Unstructured data, yes.
However, it's really unstructured data because it hasn't gone through an analysis or filter
Yeah.
to make it structured.
Mm-hmm.
So if there's a model built for the known data element, let's say that's a machine learning model, what's a good way to take the unstructured data and filter it? Could you use that same model? Are there ways? And I guess how do you build machine learning around unstructured data?
It is, yeah, as you said, it is unstructured. Oh, I have to repeat the question. So the question is, all these models are built around structured data. We know how the data is. It is very well organized. So when we have unstructured data that is not filtered, that hasn't gone through any process, that's just raw, what do we use and how do we handle it through machine learning? So we have unsupervised learning, as I said. Unsupervised learning, when it determines into clusters, we can actually label those clusters and like make that whole thing go through supervised learning. You see two types of learnings going on. So that's one way of handling it. When I do unsupervised learning, it looks for patterns by itself. I don't have to tell it specifically that this is the pattern you need to observe. So based on the patterns, it's doing. And then, as I mentioned, reinforcement learning, I know it's a bit complex, where if your outcome is not expected, you can penalize the model. You can say, no, 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 this is not expected. You have to go in this way. So it's combination of more than one model that you go through. One model will help you organize your data. The other model will process that organized data to gather information. Helps. Any more? Any in the chat? Oh. Did I go too fast? Mhm.
Is that all that you got?
Yeah, I have gathered only that much for this because I thought it would be too much to give a lot in one session. Is that too less?
Thank you.
Thank you.
So thanks everyone. So for those virtually, I'll turn back on presenter mode so that you guys can talk amongst yourselves. Feel free to still ask questions. We'll check it periodically. And then for anybody in person, we have some food from Jimmy John's